Alright class, how are we doing today? So let's go ahead and check out this video of solutions for our review for Unit 1 exam. So we're going to go ahead and skip this problem here. This is not one that we're going to need to be doing. We didn't discuss this unit, but we did discuss unions, or this is something we did discuss. So let's go ahead and work these out here. So the first part that we've got there is m plus 5 is greater than 11. So if I'm going to isolate m, we're going to subtract 6 from both sides. I'm sorry, subtract 5 from both sides. Doing the math in my head, sorry guys. That gets canceled out, so we got m is greater than 11 minus 5 is 6. Okay? So I'm going to box this. This is important. My other side says 8 minus 10m is greater than or equal to 33. So I'm going to subtract 8 from both sides. I'm left with negative 10m. Don't forget that negative. That's usually what gets dropped by most students. Okay. And then 33 minus 8 is 25. Okay. We'll divide both sides by negative 10. Okay. This simplifies out. We've got m, 25 divided by negative 10. If we put that on the calculator or do it by hand, you'll get negative 2.5. Now we divided here by a negative number, so you need to remember your inequality sign will change. So this is important here. So let's graph this and then we'll go over the interval notation. Okay. So for the first part, m greater than 6. So I'll come here to 6. I'm going to put an open point at 6 because it is not including that 6 value. It does not have an equal sign, and we're going to the right. And for the other value at 2.5, that's about right here between negative 2 and 3. And this is a closed point. Okay, this is a closed point, and we're going to the left. Okay. So now let's talk about the actual notation. So we're going to read this from left to right. So from the left, we're coming in from negative infinity, and we're stopping at 2.5. So remember, we need parentheses for all infinities and negative infinities, and we use brackets for any closed points. Or we start off here at 6 and we'll go on to infinity. 6 will have parentheses, infinity will also have parentheses. The 6 has the parentheses because it is an open point. We never fully reach 6. And we can never fully reach infinity. That's why we have these open parentheses. Let's go ahead and go on to the next question. Alright, so we're just looking over domain and range. So remember, for domain, we're talking about the x's. For range, we're talking about the y's. Okay? So let's look at these x's. My x's are going from here. We're starting here at negative 1, 2, 3, 4. At negative 4. And we go on, we go on, we go on. And we're going to go on forever. So if we're going on forever, let's go ahead and just do this in interval notation. If we're going to go on forever, we know we're going from negative 4 to infinity. Bracket, parentheses. For my range, okay, my range, the lowest point that I get started at is here at 0. And we're going to go up, 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 and we keep going up forever. So we're going to go from 0 to infinity. Bracket, parentheses. Now, is this a function? Well, with a graph, we want to do the vertical line test. And so just checking this here, anywhere that I draw a vertical line, whether it's here, 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 I only touch once. So is this a function? Yes, this is a function. Okay, let's do domain and range for this next one. So you see we've got these arrows that are going on forever, and it's going to have this pattern. So as far as domain is concerned, we are going to be going forever in this x direction, negative infinity. And if this keeps going, we're going to see it goes forever in the positive infinity. Okay? So when we're talking about the domain, we would say negative infinity to positive infinity, parentheses, or anytime we have the situation of negative infinity to positive infinity, that is considered all real numbers. You get that fancy R there. That's all real numbers. Okay? The range, though, now the range, that's talking about the lowest it goes, which is right here, all the way to the highest that it goes. Okay, so the lowest we go is down to -1. So we're going from -1 to 1, 2, 3 to 3. And we are closed on that interval because we do touch those values. Now, is this a function? Well, anywhere I draw my vertical lines, I only touch one time, one time, one time. So is this a function? Yes, it's a function. Okay, let's go on to the next one. All right, I like these guys. I like these because it's multiple choice, and two, there's a little trick. When we did this lesson, we'll discuss that trick right now. It's asking, is this function presented and graphed with its respective inverse? So what I want you guys to see first, guys, is when we look at this, I want you to remember that there was a special line that cut through the graph, and that was at y equals x. This was our symmetry line. And what should happen is this should be acting like a mirror, okay, of the function and the inverse. Okay, now I look at this graph, and everything's happening here on this side. And there's nothing happening here. So I can immediately eliminate this as that y equals x did not work as a line of symmetry. Okay? So then, when I come to b, I see here, well look, this y equals x works as a perfect line of symmetry. So b could be an answer. We're going to come back to it. It could be an answer. Okay? We'll come over here to c. If I draw my line of symmetry, this line of symmetry does not work as everything's happening over here, and there's nothing over here. This is no good. And for D, I draw this line here. Well, look, this also acts as a line of symmetry. So it could be B or D. Now, if you have no idea how to solve for inverses, okay, this is a good little technique to use to eliminate some choices here. Okay. So let's go ahead and now let's work out our inverse. So if we say y equals x plus 5, and we wanted to get our inverse, remember the first thing we do is we switch our x and y. So we have x equals y plus 5. I'm then going to subtract 5 from both sides. So I get x minus 5 equals y. In other words, that is just y equals x minus 5, or the way it should be, after the -1 is x minus 5. And when we do that, we see that B is our answer. All right, let's go ahead and move on to the next one. So this one is just like the last one we did. Okay. Now I'm going to tell you right now, all of these are symmetric on y equals x. So this little trick that we were using on the last question doesn't necessarily work. So we have to be able to take the inverse of this. Okay? So when we're taking the inverse of this, we're going to say y equals -3 over 4x. We're going to switch our x and y. So we're going to say x equals -3 over 4y. To isolate our y, guys, I know a lot of y'all will divide by this value, or you can multiply by the reciprocal. I'm going to take it one step at a time just to make sure that everybody can follow along. So I'm going to multiply both sides by 4. So I get 4x equals negative 3y, and that happens because these 4's simplify out. I still want to isolate my y, so I'm going to divide both sides by negative 3. Simplifies out. And so our final answer would be negative 4 over 3x equals y. More importantly, it should be the inverse of x equals negative 4 over 3x. So when we do that, we want to find our answer, and we find that as C. Okay, let's go ahead and move on. All right, so we're looking to see if something's a function. And these are actually questions that I really enjoy because they're real-world examples. And so we want to determine if it's a function or not. So a couple of things that we want to remember as far as functions. It needs to have unique outputs. Okay, in other words, the way I like to explain it to everybody is, if you put a question in Google, will you get an answer? Yes or no? So let's figure that out. Let's look at A. Okay, A is our input. Okay, so if you are given the date of getting a driver's license, so if we say today we're getting our driver's license, let's say today is August 28th, okay, 2020, you put that date in. Will that tell you exactly which person, okay, not all the people, exactly which person got their driver's license if you put in today's date? No. No, it won't. Okay? That's impossible. It doesn't know. There's not enough detail in that input value. Okay? Alright, so now let's talk about a fishing contest. So we have a fishing contest where everybody's trying to catch these fish, and there's somebody named Mr. Acevedo. Okay, Mr. Acevedo is competing. If you look up Mr. Acevedo in that fishing contest, can you find out how many fish he caught? Yes, you can, right? It's a fishing contest. There should be some type of record. So yes, there is some type of record. Okay. Zip code. So zip code, that's part of your postage. That helps to determine your where you live. My zip code is 78526. The zip code of the school is 78520. So if you use these zip codes, if you put the zip code into Google, will it tell you what state it is? Yes, zip codes are unique to your states. So yes. Okay. So if you were given the age of a tree, if I tell you this tree is 35 years old, can you tell me what type of tree it is? No. No, that's impossible. Okay. Next one, if I tell you the type of bird, okay, can we find what month the bird migrates? In other words, what month the bird will head south for the winter? Yes, that happens every year, and it's always around the same time determined on the bird. Okay, and the last one here, the number of days in a birth month. So if I tell you that there's a person and their birth month has 30 days, can you tell me exactly what person it is in the world? No, that's impossible. So that is not a function. Okay, so again, that little hint, that little strategy that I like to use is think about it as, if I put this into Google, can I get a unique answer for it, an answer that works? Okay, let's move on. All right, so domain and range. I like these guys. This is a little different than the last set of domain and range problems that we did because we have like piecewise functions. And I know we haven't really discussed piecewise functions, but we have discussed domain and range. So as far as domain, okay, that is our x values. So we're starting here at 5. Check it out, check it out. We'll go to 5, then we go. We're still going, Oh, look, it stops here at 1. So we're going to go from -5 to 1. And we're going to use a bracket because these lines are closed, right? These are closed here. Okay. Or, let me do this in a different color here. Or, because we have a jump, okay, we're starting at 2, and we go, and end at 5. So we're going from 2 to 5, okay? But at 2, we have an open circle, so we use a parentheses. And at 5, we have a closed circle, so we use a bracket. So now let's talk about range, our y value. So how low does this go? Well, at low, we're going here, starting at 0. And, oh, I take that back. That is incorrect. That is incorrect. I apologize. Our lowest is actually here at -2. Okay? So at -2, we're here. We go up, we go up, we go up, we go up. We're still going up. And I know there's a jump here, guys, but that is being satisfied over here. So we never really skip a beat on this range, okay? So we're still going up, and the highest we go is here at 4. So we're actually going from -2 to 4. This point down here was closed, bracket. This is also included, bracket. If you're struggling with the range, that's okay. We're going to really discuss that more in this upcoming unit, but I really want you being able to read those domains because that's the most important part. All right, let's do another one, another domain and range. So let's check it out. So for domain and range, I know I'm starting off here at, for domain, let's go to this, let's isolate this. This is domain, which is our x's, and we're here at -7. And so we come here, and this is where stuff is happening, right? We have this open point, closed point. So you could write this, and we'll talk about this. We could just talk about this first line. You're going from -7 to -3, and it would be bracket, parentheses. This is bracket, parentheses, closed and open. And then we could say, or, okay, we start off here at -3, okay, and we're starting here at -3, and we're going, and we stop here at 1. This would be bracket, parentheses, bracket, parentheses, or, and we start off again at -1, okay, -1, and they go to 3. I'm sorry, this should be a +1. I don't know why I keep saying -1. Okay, from -1 here, a +1, we're going to use that bracket and parentheses, bracket, parentheses. So this is for the domain. Now, you could do this like that because we have all this jump discontinuity here. But really and we'll discuss this when we talk more about piecewise functions, these like little bridges here that you see from -3 and here at our 1 values, we could really just write this from -7 to 3 as our domain. But don't let that confuse you. You can break it down into parts that will work for this lesson. Okay? Now, for our range. Okay? Let's look at the lowest that we're going. So our lowest is here at -7. And we go up, 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 and we stop here at -3. So our lowest is -7. That's going to be a bracket. Then at -3, that point does exist here. So that'll be closed with a bracket. Okay, and then we continue on, or we start here at -2. Let me pick a better color. I'm sorry, not -2, at +2. And we go up, up, up until 6. and this was an open point, and this was a closed point. Again, we're really going to focus on the domain. If you can do the range, that's awesome, but the domain is what's being tested. Let's move on to the next one. All right, and then guys, so just to finish this up on this problem, guys, I apologize, we had a little jump here. To do this x-intercept, we want to set x equal to 0, I'm sorry, y equal to 0. So we're going to see this as 4 times 0 equals 10x minus 24. 4 times 0 is 0 equals 10x minus 24. Okay, we'll go ahead and subtract 10x from both sides. So we get that variable on the left side. So we get negative 10x equals negative 24. Divide both sides by 10, actually by negative 10. So we get x equals, and if we're going to put this in a decimal, because I know we're graphing this, this would be a positive 2.4. Okay, negative over negative is positive. 24 divided by 10 is 2.4. And so our point for our x and our y, okay, is at 2.4 comma 0. So let's go ahead and graph that. So 2.4 is somewhere between 2 and 3. So comma 1, 2, 3. So it's somewhere here in the middle. Okay, make sure that point stays. Let's do the y-intercept. So we're gonna set x equal to 0. So we're gonna say 4y equals 10 times 0 minus 24. We get 4y equals 10 times 0 is 0 minus 24. Divide both sides by 4. So we get that y equals negative 6. So then our point would be at 0, negative 6. So I'm going to start here at 0 and I'm going to go down 6. 1, 2, 3, 4, 5, 6. And then we draw our line. Okay. All right. Let's go on to the next problem. And this is the last one for today, guys. And this isn't something that we've already done, but I want to make sure that we just really emphasize this. So let's talk about our domain. That's our x values. So when we're coming in here, we know we're coming in from negative infinity. So we're going to write that down. Let's do a different color here. Negative infinity. And we go, we go, we go, we go, we go. Oh, we stop here at negative 1. So open parentheses, because we can include negative infinity, and open parentheses because, or close parentheses because that negative 1 value is not included. Okay, or we start off here, all right, with this point here at negative 1, and we go, we go, we go, and we're actually going to be going to the right for infinity. This is a close point, so we're going to use bracket parentheses. If we were going to discuss this as far as like, is there a simpler way of writing it? Yeah, these like this at here at negative 1, we have this jump here, and so actually all points are being included on this. And so let's see, what does that look like when we're including all points? Well, we start off at negative infinity, and we're going on to infinity. So this would be the same thing as this fancy R, which is all real numbers. Okay. Don't worry about the range on this, guys. We'll discuss range next unit for unit 2. I hope this video helps, guys. Make sure that you finish studying this weekend, and we'll see you on Monday for your exam. Bye, guys.